All right, this is question number 18 for the practice final. What we look here is we notice that we have a trinomial and there are numbers for A, B, and C. So we ask ourselves, does this have a GCF? And in this case, we do not have a GCF because 9 is 3 and 3 and 8 is 2, 2, and 2. So we're good there. We are then going to take the kind of the AC method, which is take the first and the last and multiply them together. I order these smaller and greater. So the smaller one is a 8 and the greater one is a 9. And then what I'm going to do is I'm just going to add these together. This is what I call the primer method. I just start off, add them together, and see what happens. If we add these two together, we will get 17. Okay? So 17 is smaller than the number that we have. Our number we're looking for is 18. So what we're going to do here is we are going to take 8 and we are going to go down from 8 one step. But what's the number less than 8? Be 7. Can we get a 7 from a 9 and an 8? Well, no, we can't. So it's not going to be 7. So under 7 is 6. Can we get a 6 out of this? We totally can. If we have 6 and 12, then 6 and 12 would still multiply up to whatever 8 times 9 is, which is 72. And we know that we can now add them together. And we should get a number slightly above 17, which is our 18. So notice in this method, I start right here at 9 and 8. And then all I do is take my smaller number, because it's easier to do it, and just go one step. What is one step lower or one step higher than what we have? I like to keep them in order by my smaller numbers. So in this case, I have 6 and 12. So in this case, we have a positive for our C and a negative for our B. So sum, same. B is negative, bigger is negative, which means the other one has to be negative. So all of that is just to say that we have -6 and -12 as our numbers. Before we go any further, we then have to look and ask ourselves, well, is there a number for A? Which there is. In both cases, we're going to say -6 divided by 9 and -12 divided by 9. Okay? We want to see where these go first before we put them in binomials or go any further. And this is to kind of make sure we don't make a couple of errors that are very common with this type of question. So reducing these, we know that if you take a 6 and a 9 and you reduce them, you will end up with, oops, hold on a second. This will reduce to a 2, and this will reduce to a 3. Out of the 12 and the 9, we get a 4 and a 3, dividing them also by 3. So everything's divisible by 3 in this case. Okay, so let's look at what we have left over now. We have a -2 over 3 and a -4 over 3. Because this is an equal question, we have equals 0. We can either solve it right now, or we can set it up in the kind of a proper form if we didn't have an equal sign. If we did not have an equal sign, we would say we would have 3x minus 2 times 3x minus 4 equals 0. And then we would have to solve this. So we would say, okay, 3x minus 2 equals 0. 3x minus 4 equals 0. And then solve them separately, moving the 2 to the other side, the 4 to the other side. 3x is 2. 3x is 4, divide by 3, divide by 3. And we would say that x is equal to 2/3 or 4/3. Now, because how we just solved this, the reason why I say we can just stop here and answer the question is we can go with the lightning bolt concept here. Because we have an equal sign, the opposite values of these numbers are really what we're solving. So if you think of a lightning bolt, in the sky and on the ground, you have a negative and positive charge. So if we have a negative, we would end up with a positive to make a lightning bolt. And the same thing with the 4 and the 3. And we can say that x equals these two numbers. So this method over here is not completely necessary unless there's not an equal sign. If there wasn't an equal sign, you would pretty much just keep it like this middle part here. With an equal sign, we might as well just solve the question right now, which is what we did here. So our answers are going to be 2/3 and 4/3.